CS1010X Lecture 4, Recursion, Iteration, and Order of Growth. Okay, let's take a look at what we learned last week. First, recursion is about dividing a problem, okay, into one or smaller problems. But the key here is not only that they're smaller, but they're all similar looking, right? And the general idea here is that if you're able to solve the problem for a simple base case, then you're done. All right, so this is the picture. Typically, you start with a problem of size n, and you are able to compute this n with some problem of size n-1, and so forth, right? In the end, you end up with a small number, normally 1 or 0, and this is the base case. Okay, and because of that, you are able to reconstruct the answer for n. Okay, so the basic idea is to solve the problem for a simple base case, and then you express or divide a problem into one or smaller problems, and this is very similar to what's called mathematical induction. I hope that most of you are kind of familiar, but if not, not to worry. But in case you're familiar, let's take a look at how the two are related. So in induction, you start with a base case B, right? And you come up with some general procedure to show that if K works, then K plus 1 also works, and then we're done, right? Because then it must always work for any cases that is greater or equal to B. Recursion is similar. Typically, you devise a procedure that expresses a problem of size n as a problem, or a few subproblems of size k, that k is smaller than n, right? And you show that there exists a simple base case or some base cases, B, for which you can just state the answer. This is also called the termination condition, and pretty much with this, you can compute the problem for all n, where n is bigger than B, right? So now sometimes you need more than one base case. So why don't you guys think about it, and if you have any ideas, you can post on the forum or we can discuss. Some other times you may need to express a problem in terms of another form, and then the other form will somehow link back to the present form. So this is called mutual recursion. We saw that last week through this ping pong thing, right? And another example would be some sine and cosine functions. You can typically write sine and cosine in terms of each other, right? So I believe that we may have some homework that will cover this, so you can see it later. Now let's look at some examples of how we can apply recursion. Now, some of these examples are quite mathematical, so don't get too worried and don't be frightened by the fact that the math is a little bit complicated. You don't actually have to understand the math. All you need to do is to believe that the math works, and then your job is just to write the code that will solve the problem based on the technique that the math suggests. So the first example, we have this algorithm called Euclid's algorithm. So the idea is that you want to find what's called the greatest common divisor or the highest common factor. So given two numbers A and B, okay, you can denote the remainder as R, where R is the remainder of A divided by B. Then we can express GCD of A and B, okay, over here. GCD of A and B is equal to GCD of B and R. So essentially the B comes over here and R is the remainder of A divided by B. Okay, so what happens if B is bigger than A? All right, think about that. Huh? Now, if it turns out that B is equal to 0, right, then we know that A is the greatest common divisor. So let's take a look at some examples. First, let's look at the code. So this over here is exactly what we just saw in the other page, right? So GCD of AB is GCD of BR for A and B greater than 0, and then GCD of A0 is A. So we can write the code in this form. So define GCD AB, right? Now, look at this part. Huh? If B is 0, then what? Then we return A, right? Because A will be the greatest common divisor of A and 0. Now, if not, then what happens? We will call, you return, okay, exactly here, GCD of B, right? The B from here, you put down here, and then you do the A remainder B, right? So this is your R. Well, this is really simple, and it turns out this actually works, right? So let's take a look. So suppose you have two numbers, 206 and 40, and you want to find the greatest common divisor. So this thing is equal to 40, right? And 6 is the remainder of 206 divided by 40, right? Then after that, you bring the 6 down, and you find the remainder of 40 divided by 6, which is 4. And then you bring the 4 down again, and the remainder is 2, right? And then you bring the 2 down, and then the remainder is 0, because 4 divisible by 2. And so we know that GCD of these two numbers is actually 2. Okay? Now let's take a look at another classic problem. This problem is called the Towers of Hanoi. Now in this problem, what you have are a bunch of discs. Okay, they are discs, so they are round, and the discs have a hole in the center, and you put a stick through them. Right, so this is a group of 3 discs, right? Big ones, middle one, and small one. And the general idea is that you want to move this disc from one stick to the opposite stick, and there's one extra stick in the middle. And you are able to move one disc at a time, okay? And the rule here is that you cannot put a smaller disc over a bigger disc, right? So in each round, you can kind of move a top disc to one of the other sticks, and if there's already a disc at that stick, you must make sure that this new disc that you put over this that's already there is smaller than the one that's already there. Okay, so and the idea is to move this whole bunch of discs to the other side with a bunch of moves. So the goal of this problem is to go and write a function that will solve the problem and give you all the steps you need. Okay, so this is an example of recursion. Now, how does it work? So again, let me just remind you that in recursion, you solve the problem for a simple case, and then you express the problem in the form whereby it consists of smaller problems of a similar form, right? So the question is, what happens if you have no disk? Well, do nothing, right? So next, let's assume that we know how to move 3 disks from A to C. Then, question, if we can move 3 disks from A to C, then we can definitely move 3 disks from A to B. Why is that so? Well, because you can always pretend that C is B and B is C, and then you do the same thing and essentially you move this from A to B instead of from A to C, right? So, question, now what do you do with 4 disks? Well, we simply move the top 3 disks from A to B, and then we move the big disk from A to C, and then move the 3 disks from B to C again, right? So let's take a look. This is the code to solve it. Now, this is how it goes. So the code that we need is the function that we will write is called move tower. And move tower takes a few arguments. It takes the size of the tower. That means in this case there are 3, so the size will be 3. The source, destination, aux. Okay, source is the source stick, or dest is the destination stick, and aux is the auxiliary or the extra stick. Now, first, if the size is 1, okay, that means that if there's 1 disk, what do? You print the move from source to destination. That means if there's only 1 disk, you just move the 1 disk from here to there, and we're done, right? Now, if there are more than 1 disk, then what can we do? We can move tower, size -1, source, aux, dest. What does that mean? It means you move n-1 disk from here to the aux, using the desk as the extra stick. Then, this gives you n-1 sticks here. Then you have 1 big disk on the left side. You move the big disk over to the last stick. And then after that, you move tower, the aux, to the desk. The altogether size -1 disk over here now. You move them over to the desk, and this finishes the problem. This is what print move does. Print move is very simple. Print move just says print. So the print command will print a message to the console, and you can see move top disk from source to destination. Right, that's all. Okay, let's take a look at the code. Now, this is the code that you can run in idle, and you can just press F5, and here you go. So you run the code. So now I can do like move tower. 3, size is 3, okay. Let's call the sticks 1, 3, and 2. Okay, and alright, so the result is the following. Now, this may work for you, but let me just introduce you to something else. This is called the Python tutor. Okay, so if you go to www.pythontutor.com, visualize, you will get the sign of a screen whereby you can type in your code now, and this particular piece of code will help you visualize the code that you run. So let's take a look and let's try to run the same code. Move tower 3, 1, 3, 2, right? So we're moving 3 disks from the stick number 1 to stick number 3 with 2 as the auxiliary stick. So once you're done with the code, you can press visualize. And once you do that, you will have this screen where what you can do is you can forward through the code 1 step at a time. So right now what happens is that if you press forward, it will execute this statement. So what this statement does is that it creates a variable called print move. This variable print move then points to a function print move, which is this thing. And then what this line does is that it will execute this whole part, right? And you create a function move tower again, which points to a function, right? And now this is the kind of third thing that it does. And what you do now is that you execute the actual code that moves the tower. So if you do move tower, okay, when you execute this piece of code, what happens is that you're doing a function call. So the function call calls move tower, and it actually uses the arguments 3, 1, 3, 2, right? So 3 goes to size, 1 is the source stick, desc is 3, auxiliary stick is 2, right? Then let's take a look. It goes in there, checks if size is 0, size is not 0, so it doesn't do anything. It goes to move tower. So move tower now is another function call. It will now call the function again, but this time the function call size minus 1 is 2, 1, 2, 3, right? Instead of 1, 3, 2. And then it goes inside, size not 0, it goes in there, calls another time, 1 goes in there, and then basically it goes to this part whereby you reach a size 0. So size 0, you go to this line, okay, size equals 0 is true, so you return true, okay, and then now it just returns true, and it goes back to this particular call. This call is 1, 1, 3, 2. So the next line 1, 3, 2 is print move. So now you call print move with source 1, destination 3, right? So you goes to print move, and then essentially it does a print move 1, 3. Okay, it returns none, and then it outputs to the console here, right? So this is the output for the console, and then you have this first move, and then it goes to the next one, which is it calls move tower, size minus 1 aux, desk, and source. So it's 1, 1, 3, and then you call move tower 2 and 3, right? So essentially this steps through. Okay, so if you just go through step by step, you will be able to see how the code actually executes in this fashion. Okay, so hopefully this will be helpful for you, and you should try this out for yourself. Don't just try it for Taos Hanoi, try other pieces of code that you cannot really understand. Okay, hopefully this is helpful.